Okay, we're doing section 7.2 right now. I named it already. It's similar polygons. Let's just talk just briefly, just real general, what a similar polygon is. Remember, it says similar. This is not congruent. When we talked about congruent, we talked about them being exactly the same. So I'll tell you what, let's get rid of this for right now. I just thought about this. Watch, if I copied and pasted that polygon right here. Now, it's not a parallelogram or trapezoid or anything like that. Excuse me. It's just a quadrilateral. If I took this, and let's just make that a different color just to see the difference. Okay, here's two polygons right here. I copied this and pasted it, so this should be exactly like this one. So if I took this and I put it right on top, let's see if I can get it to fit about right there. Right there. That's pretty close. And you can see that it fits right on top of the other polygon. Now, I could probably make it look a little bit better. There we go. That kind of looks like it. See a little bit of blue peeking through, but they really sit right on top of each other. So we don't say that these polygons are similar to each other. We would say that those two polygons would be congruent to each other. We're not talking about that. We had another chapter about congruent polygons, more specifically congruent triangles, if you remember that. Do you remember side angle side, side side side, all that good stuff? This is a little different. This is similar polygons. So watch what I'm going to do here. Now I know you can't see these keystrokes, but just trust me on this. I'm going to copy, and then I'm going to paste. I got the same exact polygon. It's a quadrilateral, 4 sides. Okay, and I put it right here. They would be congruent. Because, why would they be congruent? Because all the sides, all the corresponding sides, like this one right here and this one right here, they would be equal to each other. This one on the left and this one on the left, they would be exactly equal to each other. The bottom one equal to the bottom one, the right one equal to the right one. If they were congruent. Again, we're not going to really talk about congruency. I just want you to see the difference between the two. What else would be true if they were exactly the same and exactly congruent? Well, this angle right here would be equal to this angle up top here. It's top left. This top right one would be equal to the top right one. Bottom right equal to bottom right. Bottom left would equal to bottom left. So if they were congruent, if they were exactly the same, if I could take one, pick it up, and put it right on top of the other one, which I just showed a minute ago, if I could do that, they would be congruent. What is the difference between congruent polygons and similar polygons? Well, I'm glad you asked that good question. So here's what I'm going to do. I'm going to take this. I'm going to hit the Shift key. Now, we've talked about this before, but on this program, if I hit the Shift key, what it's going to do, it's going to change just the size of it. Do you see it? All the angles stayed exactly the same, and I'll show you that in a second. All the angles stayed exactly the same. I just took it and shrunk it down. That's really all I did. So look at these two. They are definitely not congruent. If I took this and moved it over, I can't get it to sit right on top exactly of the other one. So there's no way that they're congruent to each other. Let's change it to a different color. We'll keep that same pink color. All right. So these are not congruent to each other, but they are similar to each other. So let's see what we can do with this. If I took this and picked it up and put it right, whoopsie daisy. Let's try again. Okay, pick it up right here, slide it over. It's not going to fit right on top. But watch this. This is kind of cool. If I take this angle right here, this top left angle, and sit it on top of this where the angles match up with each other, let's see if they're the same angles. Now, because I shrunk it down, does that mean those angles got smaller? No, they don't get smaller. The angles actually stayed exactly the same. Watch, I'll prove it to you. Take this. If I could grab this thing. Come on. There we go. If I took this and slid it right on top of there, look at that. See that top angle right there? These two angles are exactly the same. Now, the lengths of the sides are not the same. Look, this side right here is way shorter than this big side right here. And this top side of this pink triangle is way shorter than the top side of the big triangle. But the angles are exactly the same. And I could, if I wanted to, I could take this and drag it down here. Look at that bottom left angle. That's exactly the same. Just because I shrunk that polygon down a little bit doesn't mean I changed the angles. All I did was change the lengths of the sides. See that? That bottom right angle matches up perfectly, exactly. And let's do one more since we've done the other three. Don't want to leave this one out. And then look at that. That angle right there corresponds exactly. So the corresponding angles are exactly the same. Kind of like congruent. polygons, but there's a huge difference. This is a lot smaller than this, or this one's a lot bigger than this. All right, so that's a big difference. So there's actually two things that are true about similar polygons. Let's do this in a different color. Two things that are true about similar polygons. The first thing is that the corresponding angles, write this down, that the corresponding angles are congruent or equal. We'll just say equal. So the corresponding angles, that means if I, let's just label these. I'll label it exactly the way they do in the book. A, B, C, D, and then W, X, Y, Z, as they called this one. Okay, now we can talk about these. The corresponding angles. So angle A equals angle W. Angle B equals angle X. C equals Y. D equals Z. Those angles are exactly the same. But look at this. Look at the sides, though. That's what I want to concentrate on here. AD is not the same as WZ. This one's way longer than what this one is right here. AB is a lot longer than WX. BC is a lot longer than XY. And the bottom one, DC, is a lot longer than ZY. All right, you obviously, I think, see that. But the angles are the same. So this, what are we going to say about the sides, though? We're not going to say that, actually, you know what I should do? I should write corresponding sides. Okay, the corresponding sides are not equal to each other, so we're not going to say they're equal. But we learned something in that last lesson, the lesson we did yesterday. Let me throw some numbers in here because I just want to show you what I'm talking about. Now this is all in the book. This is on page 465 if you want to follow along. So they say that the length of this one is 15, this BC is 12, the bottom one is 21, the left one, AD, is 18. All right, so they give you those lengths. Now if you come over here, look at that. They say this is 5, this is 4, this is 7, and this one is 6. Now I want you to see something about these sides. This is pretty interesting. These are not just arbitrary sides. These are not just random numbers that they just came up with. If these are similar to each other, there's got to be something that's true about the corresponding sides. Look at AB and WX. This is the top one of this polygon. This WX is the top one of the smaller polygon. What if I compared them? They're definitely not equal. Look, this one's 15 and this one's 5. This is way bigger than this. In fact, how much bigger? How many times bigger is this one than this? Well, how would we do that? We got to compare them to each other. In our very first lesson of this chapter, 7.1, the one we did yesterday when I was here in class, we make a comparison. A comparison is a ratio. So what we're going to do is we're going to do a ratio between the corresponding sides. And let's see something that's true about the ratio of these sides. So let's compare 15 to 5. How do we do a comparison? We write it as a ratio. So I'm going to write 15 to 5. Well, what does 15 over 5 equal? It equals 3 over 1. All right, let's do the other one. Look at this one. I'm not going to write all these out, but you should be able to see it. Let's compare this side to this side right here, 18 to 6. Well, if I go 18 over 6, 18 divided by 6 is what? 3 over 1, just like this is. Look at this one, 12 and 4. They're the ones that match up with each other, but this one is 12, this is 4. Make a ratio. 12 over 4 is 3. Look at the bottom. 21 over 7. 21 over 7 is 3. They all boil down. Now, if I wanted to, yeah, let's just do them all. I said I wasn't going to, but let's do that. 18 over what? 6 is equal to 3. What's the other one? 12 over 4 is equal to 3. And the last one was 21 over 7. Okay, that's good. And look what they all equal. They all equal the same thing. They all have the same, we call it the scale factor. I don't know if I said that yesterday or not. So we call this the scale factor. That's really, really important. Okay, so make sure you write that down. Make sure you at least know that you have to find the scale factor. That's super important. They have the same scale factor. Every one of these sides. 15 to 5 is 3 to 1. 18 to 6 is 3 to 1. 12 to 4 is 3 to 1. 21 to 7 is 3 to 1. The ratio of the corresponding sides all equal 3 to 1. Now, does that have to be true about every single similar polygon? Of course not, but they don't have, what I mean is they don't have to be 3 to 1, but they do have to have the same scale factor. They have to reduce to the same exact thing. If all that's true, then you have a similar polygon. Let's get another word for this. Watch. See how all these ratios were equal to each other? Anytime I have a ratio equal to another one, 21 over 7, that's 3 over 1, equals 12 over 4, that's 3 over 1. Anytime I have that situation right here, and I have two fractions that are equal to each other, I say that they are in proportion. So all the sides are in proportion. And that's what we're going to write right here. Let's change this to yellow. The corresponding sides are not equal to each other. What are they? They are in proportion. That's really important. What does it mean to be in proportion? It means the ratios of the sides have to be the same. Are they? Sure they are. 15 over 5. What is it? It's 3 to 1. Okay? This is 12 over 4. What is that? That's 3 to 1. 21 over 7, 3 to 1. 18 over 6, 3 to 1. Are all the sides, do they all have the same, do they all reduce to the same thing? Absolutely. If they all reduce to the same thing, the corresponding sides, that means they're in proportion. So two things must be true about similar polygons. All the angles must be equal. So A has to equal W, B has to equal X, C equals Y, D equals Z. We already showed that that was true. What else has to be true? What else has to, I'll tell you what, let's do this. Let's mark this. So A and W have to equal each other. B and X have to equal each other. C, put 3 arcs here, has to equal Y. They equal each other. And D, put 4 arcs for that one, has to equal Z. If all that stuff is true, if your sides are in proportion, and if your corresponding angles are equal, then guess what you have? You have a similar polygon. Alright? So, hopefully that made a little bit of sense to you. Let's talk a little bit more on how to label these things and what the symbol is for similar polygons. Let's just scooch up a little bit here. Okay, what I'm going to do is I'm going to use another polygon. Before I used a quadrilateral, 4 sides. I just happen to use a triangle. It's kind of what they do in the book, so that's what we're going to use right here. What I'm going to do is I'm going to take this, I'm going to copy and paste it again, alright, just so you can see what I'm doing. Alright, so I copied and pasted. So right now they're congruent to each other, but now what I'm going to do is hit the Shift key and grab that corner and slide it down a little bit. So what are these things then? If I copied and pasted, they have the same angles. I hit the Shift key, so I kept everything in proportion. You're going to hear that word a lot. I kept it in proportion. So let's label this. Let's change colors here. Let's label it, and we'll call it F, G, and H right there. And we'll call the other one J, K, and L. We'll call this J, we'll call this one K, and we'll call this one L. Alright? So if these triangles right here are similar to each other, let me show you the symbol, how we label this. Now, I could call this anything right here, but let's just call it, the way I wrote it down, let's call it F, G, H. Alright? F, G, H. Now what I want to do is I want to say that this is similar to this. Well, the way I drew it, F and J were equal to each other, H and L were equal to each other, and G and K. Alright? So those are the sides, or those are, not these sides, but those are the angles that are equal to each other. What I want to do is I want to set up what they call a similarity statement. Let's write that down. Similarity statement. This is the similarity statement, and this is going to be asked on a quiz and a test, I promise you, because I know exactly where the problem is and everything. There's a problem that says write a similarity statement that shows that these triangles are similar or something to that effect. All right, so what we're going to do, if I call this FGH, very, very similar to what we did with congruent triangles, the angles have to match up. So which one matches up with F? Oh, by the way, let's do the similar statement. It's kind of like congruent, except it's only just the one squiggle. There's no equal sign to it. Okay, it's just the one squiggle, and that means that they are similar. Let's just scooch this over a little bit. There we go. Alright, so FGH is similar to what? Now, if I go in this order, F, G, and H, watch, I'm going from 1 arc to 3 arcs to 2 arcs. Let's do the same thing over here. If I go 1 to 3 to 2, what am I going to do over here? I'm going to go 1 arc to 3 arcs to 2 arcs over here. So what do you think I'll call this thing? This would be J, K, L. Make sure that you do it in that order, because watch what happens. These things match up, and it's really, really important that they match up with each other. Watch, the F and the J are the same angles, so they're first in place. Okay, F and J are equal to each other, they're the first spot. Look at the G and the K. The G and the K are in the exact same spot, they're the exact same spot up here. And what else? The H and the L. See, the H right here and the L right here, they're the ones that match up. That is your similarity statement. I could ask that on a quiz or a test, and I promise you I will ask that at least once on a quiz or a test. Alright, so those are my similarity statement. That's my one similarity statement between these two right here. So we know that the corresponding angles are equal. I'll tell you what, let's just list them. Remember we had that 1 and 2 a little bit earlier? So let's list all the corresponding angles. Alright, and remember the corresponding angles have to be equal to each other or congruent. Let's list them. So angle F equals angle J. What else? G, right? Angle G equals angle K. And the last one is H and L. So angle H equals angle L. Alright, so those are my corresponding angles. They are all equal to each other or congruent. If you want to put a little congruent symbol there, I don't care. I'm fine if you say equals as well. Now what else must be true? Well, the corresponding angles are equal. Do you remember that 1 and 2? The corresponding sides have to be what? In proportion. So let's find out what sides we're going to write down here. Let's do this in a different color. Let's see what I'm going to use. Let's go yellow. So what we're going to do now is we're going to say that the corresponding sides are not equal or congruent to each other, but are in, here's the word we use, in proportion. Okay, so the corresponding sides are in proportion. What I'm going to do is I'm going to show the proportions. Now on the other example I had numbers, so it was really easy. Let's just pop up to that. Remember 15 to 5, see I put 15 over 5, 18 over 6, 12 over 4. But look, instead of going 15 over 5, what could I have done? I could have said AB to what? Not to 5, but to WX. Okay, just pretending I didn't know what the lengths of these were. I could go AB to WX, or over WX. What else? AD to what? WZ. AB to WZ. I could have gone DC to ZY. I could have gone BC to XY. I could have done that, but I knew the numbers right here, so I just stuck with the numbers. So let's go to this. Let's actually use the letters here and write our proportions out with our letters, because we don't know what the lengths of these things are. So let's just use the letters. I don't know, what do you want to use? Let's go FG. So I'm going to go FG to, or over, what? Which one corresponds to FG? Well, you can look over the triangle and see it'd be JK, but you could also use this. This thing right here is really important to us. Because look, FG, it's the first two. Which one over here compares to FG? Well, JK does, doesn't it? And I'll show you something in a second. Why you can't always just rely on looking at the triangles and saying, oh yeah, FG is the left one, well JK is the left one. Alright? On this one, it was pretty easy and you could do that. But you can't always do that, and I'll show you in a second. Let's continue with this though, and then I'll go back to this. So what other side do I have of this triangle? Doesn't matter what order you go in. Let's go FH. Alright, so FH. So what are we doing? We're comparing the left triangle to the right triangle. I don't want to mix it up. I don't want to compare on one left to right and then go the right triangle to the left triangle in the next one. Okay? If I start off comparing the left side to the right side, I have to keep comparing it in that same order. Make sure you remember that. So anyway, what do we got? FG to JK. Let's go FH. FH to what? Well, if you look at it, it's drawn real nice and easy for you, and you'd probably say JL, and you would be right. Okay, but look at this. FH is the first one and the third one. So what's the first one and the third one over here? It's JL, just like it looks like in the picture. But sometimes you can't always rely on the picture. We've talked about that before. What's the other side? GH. So let's compare GH. It's pretty obvious because there's only one side left. It'd be KL. But again, let's look up here. See the GH? GH is the second one and the third one. What's the second and third one over here? It's K and L. So I'm going to go KL right here. That's my proportion. These are the corresponding angles that are equal to each other, and these are my three proportions. That's really important. Now before I said you can't always just rely on the picture. So watch, this could This might be a little bit sloppy, but let's do this. Let's group that together. And we're going to, what we're going to do, I'm going to rotate it. What if we did like this? And you weren't really sure. Now I know I've made those letters upside down. I'll tell you what. Let's ungroup it so I can grab the letters. Okay, so this was a J, right? And this was an L, so let's write it looking like an L. And this was a K. Let's write this looking like a K. Alright, so you can't just look at it and say, oh yeah, the left side and the left side, because they're not the ones that match up with each other, are they? But how do you know which ones match up? Well, a couple ways you could do it. You could say FG. Well, which one over here matches up with FG? I mean, I could have taken this thing and flipped it too. Watch, I could have made it really crazy. See if I can do this. Group that together, and you see me do this before. Transform, let's reflect, got the vertical. Okay, so now it really looks kind of funky. And where do my letters go? What if you didn't know where your letters went, but they told you this thing? This thing is so important. Look, it goes in this order, F, G, and H. F has one arc, so look over here. Which one has one arc over here? This one. So what letter goes with it? Well, J does. Look, this one. This has two arcs. So that would be the H, right? That's the third one in line. The H and the L go together. So the one with two arcs is going to go with the one with two arcs over here, so that's going to be L. And look, the one with three arcs is G. Where is that one? That's in the middle. Which one's in the middle? K. I hope that makes sense to you. So that's how we do it. You can't just always say, oh, the left side and the right side, but look at this. FG. FG is the first two, or it's opposite the angle with two arcs. Look, this side right here is opposite this with two arcs. Look over here. Which one's opposite the one with two arcs here? JK. So which ones go together? FG and JK go together. Look at that, right there. Let's do FH. FH is opposite the one with three arcs. The angle with opposite with three arcs. Or the, how should I say that? It's opposite the angle with three arcs. So look at this one. This is the angle with three arcs. What side's opposite that? JL. So FH and JL go together. See that? I hope I'm not making this more confusing. I'm just trying to show you some little things here. I think it's pretty cool. And what's the other one? GH is the other one. Look what angle is opposite GH, angle F. It's got one arc. So come over here. This has one arc. What's opposite that angle? KL. So GH and KL go together. Sure enough, that's what we said earlier. Because sometimes they'll flip them around like this and it'll make it a little bit tougher for you. They won't just copy and paste and stick it right next to each other so everything matches up nice and pretty. Sometimes they'll take it, they'll flip it, they'll rotate, and you don't really know what they did. So where do you look? You look to this. If I call this FGH, just give it 1, 2, 3 arcs. It doesn't matter what order you do it in, but you got to do this triangle or polygon, how many sides you have, in the same order. So the F and the J equal each other. Do you see that? The F has one arc, the J's got one arc. The G and the K equal each other. G has 3 arcs, K has 3 arcs. The H and the L go together. H has 2 arcs, L has 2 arcs. Alright, I think I ran that into the ground enough. Let's do an example, and I think we'll be done after this example. Let me just check. Alright, we've got two quadrilaterals right here, and they tell you something. Okay, they don't just give you this because you don't know anything about the angles. You don't really know what sides match up with this sides over here. You don't really know much. So what they do is they tell you this. They just call it ACDF. You could put polygon in front of it. It's not really rectangular. It's not. I mean, it kind of looks like a trapezoid, but we don't know it is or not. So we just call it ACDF is similar to VWYZ. Now, this is super important. A lot of students just look at this and blow this off and say, oh, I already see the letters right here. I don't really care. No, no, no. This is super, super important because it tells you what angles go with what angles over here. So look at it. A goes with what on this quadrilateral or polygon over here? The V. See, the A and the V are first. So they have to equal each other. So mark it. That's the first thing I would do. I would mark those equal to each other with one arc. The C and the W go together. So let's put 2 arcs for C. Come over here to W and put 2 arcs for W. See? They don't really correspond, perfectly. It's not like the A and the Y go together and equal each other. All right? So what else do we have? D and Y equal each other. 1, 2, 3, and Y, 1, 2, 3. And then, of course, F and Z go together. So we'll put 4. 1, 2, 3, 4, and Z, 1, 2, 3, 4. All right, so those are my arcs. So now I know which angles are equal to each other. So if these are similar, and it says they are because it has that little symbol right there for similar, if these are similar to each other, I know my sides must be in proportion. So the first thing that I'm going to do is find this thing we talked about a little earlier, find the scale factor. So the scale factor are two sides, okay, that are in proportion, or that are corresponding to each other, and that we know both of the numbers. So for instance, look at this. Let's look at x, FD. So FD or DF, what does that go with over here? It goes with YZ. So this x goes with this 10. I don't know the scale factor for that because I don't know what x is. Well, let's try another one. Let's try this 12 right here. 12 is AF. AF. Well, which one over here goes with AF? It's either this one or this one right here. I'm not really sure. I can't tell. So what I do, look, I look at this. AF. It's the first one and the last one. Look at over here. What's the first and last one over here? It's VZ. So where's VZ? It's this one right here. So that means 12 corresponds, or goes with, if you want to call it that, 3y minus w. I still don't know both of the numbers. I want to know both of the sides, exactly what they are, not in terms of x or in terms of y. So let's try another one. Let's try CD. Well, CD is the middle two. What's the middle two over here? It's WY. So CD is 9, whereas WY is 6. Finally, I've got two numbers, or two sides, that I actually know the real lengths of. And that's what I'm trying to do to find the scale factor. So let's write that down. I'm going to compare this one to this one. So I'm comparing 9 to 6. Now when we do the scale factor stuff, it's usually easier to reduce it. So let's reduce it. That's easy. 3 goes into both of those. 3 goes into that 3 times. 3 goes into that twice. So what's your scale factor? It's 3 to 2. That is the most important thing to find when you're doing these proportions. So we found the scale factor. That's not so bad. We saw what sides corresponded to each other. We set them up as a ratio, 9 over 6, and we reduced it, and we got 3 over 2. Now remember, what's true about similar figures? The corresponding sides are in proportion, which means they all reduce down to 3 over 2. The proportions, or the ratios, all equal 3 over 2. Let's go back to this x. Which one matched up with the x? Well, the 10 did, remember? FD, let's scooch this down a little bit. Remember, FD or DF matches up with YZ. So DF or FD matches up with YZ. So I can write x over 10. Well, what's x over 10 going to equal? Remember, all the sides equals 3 over 2. So if I go x over 10, that's going to equal 3 over 2. Now, this is what we did yesterday in class. We learned how to solve for this cross multiplication thing. All right. So we learned how to solve for proportions. So watch what we do. We cross multiply. So that would be 2x equals 30, and then divide by 2, and so x is equal to 15. X equals 15. Whoops. What did I just do? Let's try this again. That's better. So x is equal to 15. So let's just jot that in right there. Alright, so cool. We got one side. That's where the scale factor came in. How did I know to make it 3 to 2? Because this was 3 to 2. That means all of the corresponding sides. This side to this side is going to be 3 to 2. What's my other one? Well, it was AF, right? Remember that? Let's go back to this. AF is the first and the last one. What's the first and last one here? VZ, which is this one. So the 12 matches up with the 3y minus 1. I'll tell you what. Let's do this. Let's color code these. I don't know. Make it yellow. All right. I'll just kind of color them so that you know which one goes with what. So the two yellow ones go together. Let's change these. Let's change it to blue, and let's change this one to blue. Alright, then you can kind of see a little bit better how they go together. Do you see that? So the two yellow ones go together, the two blue ones go together, and the two pink ones or purple, whatever that looks like, go together. So let's go ahead and now, tell you what, I'm being a little ridiculous here, but that's okay. Just to keep everything color coordinated. think it works nice. So, do you see all that work we did with the blue? Alright, and now we did this yellow, so let's make all this yellow. It only takes a second. There we go. See? Now, let's go ahead and do the pink one, and we're going to do the math with this. Remember, it equals 3 to 2. So, we're going to compare AF to YZ, or sorry, AF to VZ, not YZ. So, we put 12. Compare it to what? The purple and the purple go together, right? The blue and the blue go together, yellow and yellow go together. So the purple and purple go together. 12 over 3y minus 1. What does that equal? Well, it equals our scale factor that we found earlier. All the ratios of the sides equal 3 over 2. So I put equals 3 over 2. We're almost done. Let's just do a little bit of math with this. Let's cross multiply. Now this is important. Watch me very carefully. Don't fall asleep. Wake up. Pay attention to what I'm trying to tell you, because this is super important. This is what people forget to do. It's going to be 3 times this whole thing. So what am I going to have to do? I got to put that in parentheses. We got to distribute. So it's going to be this equals 12 times 2. Let's do the math now. Distributive property. That's 9y minus 3 equals 12 times 2, which is 24. Add a 3 to both sides. So 9y equals 27. Divide by 9. You see it already. Y equals 3. And there's your answer. So y is 3 and x is 15. And that's what they asked for. They just asked you to solve for x and y on this. Well, I hope that makes sense. Go back. I'll put it on YouTube. Alright, go back tonight, look over it again. I haven't looked at Khan Academy, but my guess is he'd probably have something very close to this. Do some research if you didn't quite get this. Watch my video again, and watch it 3 times. Look in the book, alright, to see what to do. Don't just rely on just this class period and nothing else. Make sure that you go on your own and figure this out. Okay, let me give you some problems to do. All these problems are going to be from the book, because since I'm gone, it's just a lot easier for me to give you the problems from the book and not give you worksheets for this. So let's see what I want to give you. All right, here's the problems that you're going to do from the book, page 469. This is section 7.2. All right, 469. We're going to do 8 to 15. We're going to do 18 to 21. And I believe I hit everything I need to. For you to be able to do these problems. Okay? So have fun with that. We'll see you tomorrow.